Let's go to yes.
All right, good afternoon, everyone. So my name is Sleiman. I'm a senior research associate here at the University of Melbourne, and I will be moderating today's seminar. Now, before we begin, I would like to acknowledge that today we are gathered on the lands of the Wurundjeri, Woi Wurrung, and Boon Wurrung people who have been custodians of this land for thousands of years. And we acknowledge and pay our respects to their elders past and present. So for those tuning in online today, we invite you also to acknowledge the traditional custodians of the land you're listening in from. So now, thank you all for being here as well, of course. All right. Need a little bit of a nudge.
Are you going through my presentation?
So you can get your questions in order. All right. So today is the final MEI Network Seminar series for 2024. But we would also like to invite you to the Melbourne Energy Institute Symposium on the 22nd of November, so in about 2 weeks. So this will be an in-person event at the University of Melbourne, Parkville campus. So we are delighted to host Anna Scharbeck, Chief Executive Officer of ClimateWorks Center, as our opening plenary speaker. So MEI will also host 21 different speakers on that day, and we'll also host a poster session during the lunch break. You can register, actually, you can register with this QR code. Or go to the MEI events page, basically. So now a bit of housekeeping for our online audience. If you have any questions, please enter them into the Q&A box as the chat function is disabled. So we will have some time for Q&A from the online audience and those in the room at the end of the session, where we will endeavor to get through as many of your questions as we can. Now, to introduce our speaker for today, Dr. Carmen Baz. She's a renewable energy engineer in customer assets at Energy Australia. So she's currently leading the development of different models of community batteries across the NEM, including market participation, asset management, network support, and consumer offering. Now, previously, she was a researcher here at the University of Melbourne, where she obtained her PhD in electrical engineering. During her PhD time, she focused on techno-economic analysis of distributed energy systems, including consumer energy resources. She also led various projects in the energy community space, including Power Melbourne, to install a network of community batteries in the city of Melbourne. And she also worked on the Donald and Tarragona microgrid feasibility study in regional Victoria. Thanks again for joining us. Please help me welcome Carmen.
Well, thanks, Sleiman. Thanks for the introduction. So before I start the presentation, I wanted to provide a brief disclaimer. So as Sleiman mentioned, I am an electrical engineer, and I've been working in this space for a while. I was a researcher at the University of Melbourne. Now I work for Energy Australia, but of course I'm aware of the amount of knowledge that I'm still to acquire. So these are my learnings and experiences and my opinions at the end of the day. So now, that being said, the real presentation, well, I think you've seen this picture already when Sleiman gave a sneak peek, but I want to start this presentation with an introduction to the biggest decision makers in our energy transition. Because the energy transition is not only a transition in technology, it's also a transition on where decisions are made. And we're seeing increasingly that decisions are being made around dinner tables, in family gatherings, friends gatherings, instead of investment boards. And I think this provides some opportunities and challenges that makes a very exciting space to work in. And that's what I want to talk about today. So this energy transition and this change in the decision making comes from a context of achieving a net zero economy by 2050. around 200 countries have these objectives of achieving the net zero economy, increasing renewable energies, enhancing energy efficiency. And Australia is one of those countries. And if we want to understand how it looks for Australia to reach those objectives, the best way or the best place to look at is AEMO's integrated system plan. So I'm sure if you've been into these seminars, you've looked at this picture and you're familiar with it. So AEMO has some objectives on installed capacity that we need for 2050. And essentially in this figure, we see two buckets. The bucket of non-dispatchable capacity, that is our variable generation, like solar and wind, and our dispatchable capacity, that's more controllable resources that can be operated for the energy system. In particular, AEMO's responsibility is to operate the system in a safe and reliable manner. So this, it makes sense that AEMO is having that sort of view of dispatchable and non-dispatchable resources. However, I think this story also tells a consumer-focused view. It tells us that there is three buckets of resources: CER, that's consumer energy resources, and DER, distributed energy resources, solar, and passive storage and coordinated storage that essentially is being decided around dinner tables. That is actually around 50% of the installed capacity in 2050 in our system. So I hope now you don't think I was exaggerating when I'm saying that these are the most important decision makers, because I don't think there is any developer in the NEM that has 50% of the capacity. So consumers are at the center of the energy transition. But at the end of the day, I'm also an engineer. I also care about cost-efficient, safe and reliable operation of the system like AEMO. And I look at the 40 gigawatts of coordinated CR storage, and I realize that's 50% of the dispatchable capacity. So it's a very critical aspect of the energy transition that we need to solve to have a safe and reliable system. So we know where we have to go in 2050, but where are we today? So for every 100 Australian households, we have 30 solar homes. And out of those 30 solar homes, 6 are equipped with a battery. And then I wonder if you have any idea of how many of those would be considered coordinated storage. Anyone in the audience knows? PhD students? No? Well, there is only one. So I think we have a long way to go to reach those 2050 objectives of having most of our CR storage being coordinated. But before we go into detail of this coordinated storage, passive storage, I think it's important to define the terms. So here I have an example of a solar and battery home. It has a load, a demand during the day. It has solar. This is this storage here. And it has a battery. And if we're talking about passive storage, we usually talk about a battery that has a fixed algorithm operated for an objective. Most of the time is following the customer load. In this particular example, is following a time of use tariff to reduce the bills of the customer. But the most important part is that the battery is essentially blind to whatever is going on outside the home. So essentially it's not responsive to events that take place outside the home. Now, that same battery and that same customer could be a coordinated storage if it's actually responding to whatever happens outside the home. So let's imagine at 2:30, we have a large generator that has an outage. So we have a lack of supply in our energy system. If this was a coordinated storage, a third party would come in, would take over control of the battery, and would discharge the battery until it's empty at the beginning when we have that sudden loss of supply. And then until the system is back to normal, it will make sure the battery doesn't charge regardless of whatever the customer does. This is just an example. There is a lot of ways to do coordinated storage, but the key principle is that responsiveness to other things that are happening in the system. And how it's done now is essentially a customer is providing access to a battery, to a virtual power plant. And in exchange, the virtual power plant provides a financial incentive to the customer. Now, I think if you're in this presentation, you probably care a lot about energy, the energy transition, and you see this in a very rational way. Okay, I care about energy. I'm providing a service to the system. I'm helping to keep the lights on in Australia. I also get a financial reward. So, but the VPPs are great. And I agree with you. Most people agree with you, but they don't want to join one. This is some findings from Project Edge a couple of years ago. And I've been in this space for a while. So I've heard why people don't want to join one. So some of the comments is they don't want to give control to someone else of their battery. They just spent a lot of money on a piece of equipment. They are worried that that third party, that VPP, is going to thrash their new toy. So I think we have a long way to achieve those objectives of coordinated storage. And I don't have the answer, and I don't think anyone has the full answer, because it's a complex sort of set of circumstances. And it's a complex solution that involves not only engineering, it involves education and engagement to people. It sometimes will involve technical standards, so having mandatory services for this CER. And a good example is that Victoria's emergency backstop that recently went live. The possibility of having other home storage. So not only we have batteries, particularly as we electrify homes, we have other resources like electric hot water systems that could be used dynamically to provide benefits to the system. We can better understand what customers want when they to sign up to a VPP and refine the VPP offerings. And we also have new opportunities. So as the industry evolves, we will have new projects that provide opportunities to increase the CER storage. And that's what I've worked on most of my career. That's what I want to talk about today. And it's, good examples are community batteries and microgrids. And it's not only I say they are good examples. In general, I'm seeing a lot of excitement in this area. And I like the excitement, I like this area, but I think it's important to understand the fundamental concepts of these community level type of assets and understand if they are actually supporting the energy transition, if they are an efficient way to reach our goals. So the first concept is what is a community level asset versus what is a private asset. And the easiest example is with private and community batteries. So a private battery directly connected to a consumer, and as the example I showed before, that battery will be operated for that specific consumer's benefit. Whereas when we talk about a community battery, this might be connected at the network or perhaps at a specific relevant building in the community, for instance, the library or the council house, and it's operated with a shared objective to benefit the whole community. There is a lot of attention, as I mentioned, and there's been several reports talking about the benefits of this community level type of resources. And I've put them here into buckets. The first one is the non-technical benefits. And I think probably the most compelling benefit, at least in my view, is the first one. So when we talk about CR storage and solar, we're thinking about a standalone house that has the ability to have a solar and a battery, but not all Australians live in that house. I personally live in an apartment, I rent the apartment, and I don't have right now the money to spend on a battery and solar panel. And I think there are a lot of people in my shoes, but they want to participate in the energy transition. So we will always have people in my circumstances. I'm sure a lot of you also are in those. And that with community level assets, we can, for the first time, access the benefits of this type of resources, access the benefits of the energy transition from the customer side. Then as well, another benefit is the reduced investment. So because people are teaming up and sometimes they have access to other funding opportunities like government or retailers or distribution companies, that initial financial cost, that is a big barrier, is reduced. And especially in regional projects, regional community level projects, they can increase the local jobs and enhance the economy in the region. And The technical benefits is probably what, as an engineer, I spend the most time. And as I mentioned before, I think is the ones that is very important to analyze, because if you work in this industry, if you're interested, I'm sure you're aware there are a lot of challenges to be solved. So we want to invest in efficient solutions, and solutions that are holistic and provide us several benefits, not only invest because we like the idea. And the benefits of community assets are the following ones that I've put here. So the first one is the demand and generation diversity. So instead of operating an asset just following one family's demand, you can operate it to follow several families' demand, several homes. We can also, similarly, you can also operate as a little portfolio, your community, and have some benefits from aggregation. Another benefit is the fact that the community batteries or any community level asset is usually larger than a private asset. So we will have some efficiencies and benefits of economies of scale. And then you can access some benefits that would not be otherwise be able to access, like community level use cases, improving the resilience and reliability of a whole community. So, because I don't want to forget about why we're here, that is the people and the decision makers, I wanted to put myself in the shoes of a consumer and assume this family here celebrating Christmas is actually 3 families, and they live next to each other. Each of them have a solar panel, and they are a little bit upset because the feed-in tariffs have been reducing. So they are considering to install a battery. What should they do? So I think for this sort of example to be realistic, we need to assume that there is a retired engineer in this group, because no one would start doing this sort of analysis. But they have read about community batteries and they're excited about that. And they decide to try to analyze if they go with option A, they each install their own battery, or if they install a single battery and they start sharing their energy flows and their solar and fully access the technical benefits that I mentioned before. So once that retired engineer starts looking at the data, so they all have smart meters and they are able to get pretty detailed data on their consumption, they realize that the 3 families have very different consumption patterns. The first family is all back to the office, so they have demand in the morning when they turn on the kettle and in the evening when they get back to work, but not much during the solar periods. The second one works in shifts, and it has is what I call the night owl, so it has some increased demand when they turn on the microwave after coming from work and later in the night as well. And in the number 3, I would assume it's a family with young kids, and that's why they have these sort of crazy demand patterns, and they haven't been able to do the proper gardening and take care of the trees that is shading the solar panel. So if they each install a battery, we see very different battery behaviors. In the first case, the battery is empty for a big part of the morning because they have a high consumption during the morning. In the second case, the night owl, the battery is not being able to be fully discharged and it gets full very quickly. And in the third case, because there is this big demand pattern as well as reduced solar, they are not able to fully charge their battery. So I think it's quite intuitive that there are some synergies on how they use demand and their solar generation, and a community battery could benefit from that. And in fact, when we look at the same capacity, total capacity installed, but only in one community battery, allowing to share that solar and energy community and community battery flows, we see that at no point we have this idle capacity in the battery, and the battery spends less time being empty, less time being full. They compare the results and they realize, so option A is the 3 private batteries and option B is the community battery. They all have the same installed capacity in total in the community. And they realize that with the community battery, they require to import less energy from outside the little community they have created. And they are also able to use all the solar exports that they are produced by sharing that solar. And this has also financial implications. So they look at their daily energy costs and they see they get better results with the community battery, to the point that they could actually reduce the total capacity installed, essentially kind of remove one battery and get around 10 kilowatts of capacity and get the same results as if they had those 3 private batteries. So considering that the investment in storage is one of the biggest barriers we have right now for people to invest and access this technology, this is a pretty massive benefit. However, unfortunately, I think someone needs to give these people a reality check. This is not how our system works. And 3 customers cannot go in and decide to form a community and share their solar and battery. So we have different meters and NIMIs that are metering all the energy import and export that is coming in and out of the house and the battery. And there is no straightforward way to share that energy. And as a matter of fact, customers will pay the same if the energy comes from their community battery or from the neighbor's solar than if it comes from the upstream grid. Really, the only solution they will have, or at least I could think of, I'm keen to hear if anyone has another solution, to fully realize the benefits that I've shown, they should create an embedded network at the community interface. So that's very unlikely, if not completely impossible, that 3 customers would be able to make this change. So now I think here what we face is, okay, we know that these community level assets can provide benefits to the customers, to the system, but we're not able to fully access these benefits in a straightforward manner. And I think one of the key aspects, one of the key sort of limitations is the fact that we really don't have an established regulation for these projects in Australia. Whereas, for example, in the European Union, they have a regulatory framework on energy communities and actually can help us to frame our thinking here in Australia. So the first thing is that energy communities organize citizen-driven energy actions. And the community members, they can team up with other players like retailers or distribution companies and invest in energy assets. And these energy communities are operated to access all value streams that they provide, access all suitable energy markets. So that to me kind of also points out to that coordinated sort of resource and storage point. And finally, they are technology agnostic organizations. So the European Union didn't force that, okay, these energy communities have to be microgrids or have to be an embedded network or a community battery. So providing a lot of flexibility. The way that I see it in Australia is that we now have an opportunity to start informing regulatory development of what needs to happen to have these successful type of projects. And that's what I want to talk about next. So the successful community projects was a part of a project that I did with my colleagues at University of Melbourne. And the first step was, if we're going to inform regulatory developments for these type of projects, we need to understand what actually, like a wish list or what would be a successful project. So, of course, we cannot forget community is in the title. We cannot forget about the community. And what communities care about is lowering their energy cost most of the time, and in some cases being more self-sufficient. But as I've mentioned several times today, the energy transition brings challenges, particularly to distribution networks, as we see more rooftop solar, more constraints in the distribution network. So we need to provide benefits to the energy system. They need to be cost efficient and provide operational benefits. And last is that they need to be commercially feasible. So many times we need to operate in markets and services which communities don't really care about, but without that, the economics don't make sense. If we don't achieve that benefits to the energy system, the community will be happy, but I don't think distribution companies will allow the connection process of these projects to be simple and will promote that sort of connection process. So that will be a challenge for these projects. If it's commercially feasible and it provides benefits to the energy system, but we don't care about the community, I think only people that attend to energy seminars will be happy. I don't think communities would care about them. And if we don't achieve that commercial feasibility, we may get some proof of concept projects, but we won't get actually projects on CER community deployed at scale. So these type of projects are successful when they lie in the balance of these crucial aspects. But it's not only three little elements here that we need to deal with. We need to deal with a lot of factors, different technologies, different regulatory frameworks. So it's a challenge, and it requires the collaboration and the brains of many parts of the industry. So what we did in this project, this was a Donald and Tarragona microgrid feasibility study. This was a project with a lot of parts, and one of the last parts was actually a collaboration with a team that was expert at the University of Melbourne. They are experts on regulation matters, and a team of engineers. And I think it was a really interesting work because of that collaboration that is very much needed for these projects. And we were doing a what-if scenario. So we were thinking about this framework of successful energy projects and how can we unlock those successful energy community projects beyond microgrids. So the project, the specific case study was in Tarragona, which is a remote town. It's around 300 people, and it's supplied through a 70-kilometer feeder. And that feeder goes through a forest that you can see here. Like you can imagine in summer, in a hot day, there's a lot of high risk of bushfire. So actually it was a really high value location that would benefit from a microgrid. So we assumed that there was, or we studied a potential microgrid that was formed with a hybrid system of a battery and a solar panel. And we started trying to understand how could we achieve that successful project. And the first step was to understand how could we meet the community objectives, how we could meet them efficiently. And we were testing different options to reduce the energy cost of the community. The first one was having those assets to be operated independently for market purposes, and the customers would be having their usual demand, as in meeting their demand as usual, like we do at their house. They have a retail bill and so on. The two second options was, what about if the microgrid that has a very sort of clear boundaries would act as a single entity with respect, like here, with respect to the upstream grid? And we tested accessing to the wholesale market, so being wholesale market exposed, which is way more volatile, or being retail market exposed with a sort of tailored retail tariff. And we found that no matter what option, that single entity behavior was more beneficial and consistently showed a reduction in energy cost, more reduction than the first case. So that flexibility for these type of projects to allow for that single entity participation was really important. However, unfortunately, it was not enough to make the project economically feasible as a whole. So we started looking at what markets and services the microgrid or the community assets could participate in. And the most straightforward one is to engage with a retailer or an aggregator to participate in FCAS. However, this was an analysis done with historical data, but year to year, you could see that the revenues from FCAS were very uncertain. And as a matter of fact, a lot of people doing market modeling predict that they're gonna be reduced. So communities do not have that sort of risk appetite to be exposed to these prices that are very changing and very uncertain. So we look at a different option, at a different sort of value streams, which were network value streams. So particularly in this case, because it's a location where it's a high value location, where there is real benefits that this microgrid could provide to the network, we saw that there was significant economic value in providing these network support services. And as a matter of fact, they were more consistent, and we could hedge against the risks of participating in this system level market service. So essentially involving the DNSP and the DNSPs or distribution companies being incentivized to use assets as non-network solutions was very important for these projects. And the last step that we did was, okay, so we have tried to reduce the energy costs. We tried to improve the economic feasibility of the project, but what is the impact on the rest of the system? So especially because of the battery was following market prices, we saw that the peak demand and peak generation of the community at this point of connection on the picture with the upstream grid had increased. That this means that if microgrids were being deployed at scale, we would end up having to augment the network to get all those, to be able to withstand all the batteries being following the market prices. So there needs to be a better way to manage that sort of increased peak demand and peak generation that doesn't end up being causing network augmentation. So what we looked at was, what about if we deployed specific network tariffs for this type of projects? What happens? What if we align that economic profitability? So we're actually providing significant price signals to the assets, while incentivizing that behavior that we want from the assets. So we found that that was actually quite effective, reducing the impact of the negative impact of the battery participating in markets. And essentially that sort of reform to enhance network tariffs and change network tariffs to value the flexibility of these new assets and of these new projects is very important. And if retail tariff innovation follows that, instead of this type of projects or these energy communities being falsely exposed, but they are exposed to a retail tariff that is more, that properly values the flexibility, but incentivizes good behavior as beneficial behavior, I must say. Of self-sufficiency would be very beneficial and would align that economic feasibility, reducing the energy cost and benefits to the system. So as a summary, I guess this is some sort of wish list to regulators. I don't know if there is anyone in the room or online that is a regulator, but the first thing is that we do need to define some sort of energy community concept in Australia with enough flexibility for innovation. So not a prescriptive regulation of a microgrid, of a community battery project, but there is a lot of innovation right now in this space. So we need to have flexibility enough and allow that sort of achieving successful projects. The second item was related to also flexibility in a way, which is if the most beneficial way for these projects is the most beneficial in terms of reducing the energy costs is to allow these projects, these communities to act as a single entity, and they want to do that, allow it. Especially in the case of microgrids, it provides more economic benefits. And we have existing frameworks that allow that. That's embedded network or standalone power systems that with some tweaks could enable this regulatory development. But I must say that it's really important that we protect the choice and the interest of consumers, because that will be the purpose of that regulatory development. The third one is related to the distribution companies. So I would like them to be properly incentivized to engage in these projects. First of all, because these community level assets provide tangible and measurable benefits, operational benefits to the distribution network, and should be rewarded. And they may actually be a really relevant value stream for these projects to make sense financially. And then the last point is regarding network tariff development. So continue innovating to align economic profitability with the efficient use of the network. And I believe retail tariff innovation will follow to further unlock more of these projects. So this was the wish list, but I didn't want to finish the presentation with, just kind of like a view of, oh, this is all the things that need to be done. Until this is not changed, these projects are not going to be successful, because the reality is that we are now at a very sort of innovative time within the industry, and things are happening and projects are being successful. And there are solutions today and proof, especially in terms of proof of concept, which I want to talk about, and I'm part of those solutions at my current position, which I'm really happy about. So I wanted to talk about community batteries because this is one of the most prominent sort of type of project that we're seeing. As you can see in the little newspaper ad, newspaper news there, there's been a lot of funding requests from ARENA. ARENA has two streams, one for the distribution companies or the NSPs and one for third parties. I'm going to talk about that stream of the distribution companies. So how these projects, so ARENA is funding these projects as a proof of concept to understand if this is a feasible and cost-efficient, commercially feasible, and provides benefits to communities. So essentially to understand if it's a successful energy community. And the projects are essentially based in 3 pillars, which are the pillars that I just explained. I think I'm spoiling it for you, the surprise. But the first thing is that they install community batteries in high-value locations, and they are providing benefits to the distribution companies, to the network, and to all of us by extent. And then the distribution company, once they choose the location, once they understand the network value of that battery being located there, they are engaging with retailers, and the retailers are making the batteries or operating the batteries to participate in markets and services, and that is enhancing the economic feasibility. And then the last point is that there's been some significant network tariff innovation that is actually passing through the network benefits to consumers. And that, in my work, I work with Energy Australia. We have partnered with Ausgrid on this new network tariff innovation, and beyond my current position, I think is a very sort of exciting, topic to discuss, because like a little bit more than a year ago, I was doing my PhD and I was looking at how to pass through the benefits to consumers. And one of the options, you're doing research, you kind of have a blue skies approach. One of the options was local use of system tariffs as a feasible way to actually make a reality that community benefit sharing. And 1 year later, being part of a project and seeing that in Australia, we are actually delivering this and implementing this, actually says a lot about where we are as an industry, how we are innovating for the benefit of the customers. And I think it's really exciting. And in the case of Ausgrid, essentially we have a community battery connected close to demand part, and we have the community battery being charged during the high solar periods, and during the evening prices are high, the battery is discharging, meeting the consumer demand. And as a result of meeting that evening peak demand locally, if not all, most of it, we're seeing that we're reducing the use of that transmission and distribution network to the extent that perhaps there is no need to invest as much in this part of the network, the part on the left. What Ausgrid has done as a result is provide a reduction on a network tariff in the peak period, up to 60% reduction compared to their usual time of use tariff. And this is open for any retailer that wants to adopt this tariff, and passing through the benefits directly to consumers. It translates to cheaper retail tariffs, cheaper energy bills, which, Energy Australia is doing with a new product called Community Batteries. And I think it's a very exciting first step on actually delivering these successful energy communities and delivering the benefits to customers. And that's all for me. Just an acknowledgement to all my colleagues at Energy Australia, Ausgrid, University of Melbourne, and they have been involved in these projects. I've learned a lot from them, and in a way or another, they are part of this presentation. So yeah, that's it.
With questions from the room. Does anyone Anyone have a question?
So-
The online.
Thanks. So in the case study, it is pretty clear to see that the main benefits that community batteries can provide are in intangible services that most customers are not familiar with, such as self-reliance and providing services to the network. So it seems that education needs to be a big part of this challenge to motivate people to actually apply for this. What's your opinion on this topic?
Thanks for the question, first of all. And I think you are right in a sense. In another sense, I think you're not. So, like self-sufficient, I don't know if you meant self-sufficiency or self-reliance, but network benefits are actually very tangible for customers. So if you go to regional Victoria and you talk to people that, I don't know, they have storms and they are 2 weeks without power, network benefits are very real for them. But it's not only about that network benefits, as in realizing those. So what customers realize most of the time is lower bills. That's the number one thing they care about. But these network sort of benefits that would be from a third party that's operating the battery and a distribution network, and that would sort of outweigh the cost. And the more benefits there are that are stacked up, actually, the more benefits you can share with the community through lower bills, or there are different ways to share benefits that now we're seeing in the context of community batteries. And last point, and that's related to that Ausgrid local use of system tariff. If we actually manage to reduce the cost of operating our network, that translates into lower network tariffs, because in the end of the day, they are recovering the cost from investment in the network. So maybe not a very direct benefit, but the more cost efficient we are in the way that we operate and invest in our network, that will eventually benefit customers. Not that being said, I think education is extremely important, as you mentioned.
Any other questions? We do have a few questions from our online participants. So the first one is from Tim Forsey. So the question is, what size scale slash scale of size of largest community battery? And what is the range of size that describes community battery scale? So basically, when do you start calling community battery at what size versus a private battery? I think this is what I understand.
Yeah, I think that's a really good question. Look, most of the time, what we're seeing in the industry is that there is a threshold of 5 megawatts from AEMO. So beyond 5 megawatts, AEMO, the asset is centrally dispatched by AEMO. So essentially, community batteries are below that threshold to have that sort of relative advantage. And then in terms of minimum size, I've seen as small as 40 kilowatts. That would be like 8 home batteries. Now, my view as well is that it's not about the size, but on how you use it. Like, if you're benefiting the community, that's the key important factor that defines community rather than that size.
There is another question. It says, do you believe we will have rebates or certificates for batteries in Victoria anytime soon, similar to what we have seen or what has been approved in New South Wales? Just been approved.
I'm guessing they are talking about PDRS, perhaps, in New South Wales. No?
So yeah, it says rebates or certificates.
Yeah. Look, I'm not sure. I'm not sure. I don't have a line of communication with the government, hopefully.
I guess stay tuned to Carmen's work. Another question, have you followed the AEMC's recent rule change that's on integrating price responsive resources? So this is all about integrating CER into the market.
Yeah.
So if so, do you suggest any additional benefits to better allow for community resources?
I think there are So I'm not an expert on this rule change, but I've followed it. I've had some following on it, and I've seen some figures. So I think it definitely provides some benefits because that it allows for flexible trading arrangements. So perhaps not sure to the extent of having that single entity, but it allows for different NIMIs in allocation, but trading in different ways, having a retail market sort of in one side, spot exposed. And I think that sort of flexibility that it provides is really important for this type of projects.
Yeah. Tristan is asking, how do community battery developers know where a high value location is? It's a good question.
Yes. Look, if the distribution company is the community battery developer, they will know for sure, because, well, they have a ring fencing sort of waiver, so they can install those community batteries. We're seeing that. So obviously that is like a relative advantage this distribution company-led projects have. But I mean, I think it's all about collaboration. Is if I can provide a service as Energy Australia to a distribution company, and actually I'm reducing your cost to operate, why would you not share that information? And I think in general, you see openness to collaborate.
Yeah. I have a question from Nick Mason-Smith. He's asking, he's basically saying that the LUOS, which is the location / virtual storage, was called a Ponzi scheme in the AFR because if customers benefit financially without changing their load, they are being paid to do nothing. So what is Ausgrid paying these customers to do? That's the first question. And I'll let you answer that. And there's another question.
Okay. Look, I don't think it's a Ponzi scheme. And it's not about paying about like doing nothing. It's actually really acknowledging there are network benefits that are being provided and being targeted to the area in which those benefits are provided. But those benefits are not specifically coming from the community changing their behavior. They are coming from installing a battery there. So I think it's a Ponzi scheme, to be fair. Yeah.
Another part of the question, since we have time, shouldn't the benefit flow to the battery owner who can then distribute this benefit to the community, within the community, if the project is built in that way?
Look, I think there is a very sort of innovative space, and I think that could be a feasible solution. I want to say that Ausgrid is not giving money to anyone. Ausgrid is giving a reduced network tariff with certain areas that are eligible, and retailers can sign up to that tariff and then provide a better sort of energy plan and eventually reduce bills for consumers. But yeah, I think there are a lot of options, and I think it's a very new space. So we're all exploring how to transfer those benefits to communities.
So Wenqian is asking, first of all, she's saying, hi, Carmen. Thank you for your informative presentation. In the context of microgrids, do you think integrating demand response with community level resources is feasible?
Yeah.
Yeah, it's not very clear from the question, but it sounds like it's this pretty much the...
Yeah, as in behavioral demand response, I'm guessing, or from the assets. But yeah, I think in both cases, I think it's feasible, and behavioral demand response is something that can provide a lot of benefits, especially if you have that flexible asset.
Okay, and a follow-up question from Wen. What are the most promising research directions or technical requirements for making this integration effective? Research directions, right up your alley.
Technical requirements.
Making this integration effective. I mean, you touched on a lot of those already.
Yeah, I'm not sure if I understand the question.
Yeah. Okay, so how can we collect the related data? I guess she's asking about, Wen's asking about, so research directions or technical requirements in light of, let's assume it's a research context where you need to collect data from from the NSPs, or I guess what they're trying to say is, do you have any private data that you need to access in order to allow researchers, for example, to look into this and basically help in that
Yeah,
roadmap?
I think demand data from real customers is always really valuable. A network that, especially once you go into trying to quantify the network benefits, is really valuable as well. That data is not straightforward to get. Market data you can get from AEMO's webpage, so that is something useful as well in terms of requirements.
Network data, it's
Network data is hard to obtain. I think you often need to be part of a project involving the networks.
Yeah. Especially on the low voltage side. Sometimes you don't even have visibility over, even if you own it. Tristan is asking, how do you think a community battery should be compensated for an action that benefits the network, example, peak demand, but detracts from the earning potential in energy markets? So, i.e. opportunity cost.
Yeah.
That's a good question.
Yeah, that is a very good question. Look, I think it depends on how the project is framed. I think distribution companies, they do network tariffs, so they are able to put a price into demand. They are able to put a price on energy, and through planning problems, they can provide a number, like a dollar figure, to what is their benefit to the network. Now, as sorry, I forgot the name, but as the question asked, the opportunity cost to do that, like there is an opportunity cost, but then at the end of the day, if the distribution company is not willing to pay enough, then they will not get the service. It's a competitive market. So it also, I think, it provides a nice trade-off of market can be very sort of lucrative at some points. There are very high prices are volatile, and these assets can make money on that. And distribution companies need to be aware of that. But again, network infrastructure is very expensive. So in those high value locations, if you find them, I think there is a lot of value on them, and that's essentially based on previous research.
So Glenn is asking, it's not a short question. So let's see if I can sort of flesh it out. So Ausgrid and many other DNSPs have in the last year brought out new standards for new housing estates, reducing the number of houses per 500 kilovolt or kVA kiosk subtransformer from 200 or over 200 in a few years ago to well under 100 now, to meet demands for all electric housing estates. So the question is, assuming that this comes at an additional cost, is it the case that a community battery next to each kiosk subtransformer might help lower this recent cost increase by smoothing out peak demands on the transformers? So
yeah, I agree. I think it's a real opportunity there. Yeah.
Yeah, I think you touched on this as one of the technical benefits. Okay, what is Tristan again asking what is the all-in delivered cost of a community battery on a dollars per kilowatt hour basis, and how does this compare to the uncomplex and rapidly installed behind the meter home battery? All delivered cost. So basically,
Costs.
Dollars per kilowatt.
Yeah, there is
or dollars per kilowatt hour.
I don't have definite numbers. There is a lot of published data. I was reading the other day, someone reported $2,000 per kilowatt hour for community batteries, and it's true that some people report private batteries or the behind the meter batteries to be lower, but this is just starting community batteries, and that economies of scale. And once the industry sort of gets a hold on how to deploy these projects, I think there is a lot of opportunity to reduce that cost per kilowatt hours. But just it's been in the news recently, so I recommend to type it on Google and you will find it the exact data.
Question from Dennis. This is something I think you also touched on a little bit, but it's good to revisit this topic. So what is your view towards the ownership of the community battery? For example, community organization owned versus DNSP owned? Which one is more preferable?
Yeah, that's a good question. I think, especially as of now, there is not a sort of bulletproof project of this is better. I think it's a case by case. So I think the economics are affected, and that high value location, for example, is something that is easier and is needed when there is a distribution company, at least right now. But I mean, community groups, I think, will play a role, but we need to have some sort of process for them to be able to do that, because not all community groups have the capabilities to deliver these projects. This is complex to deliver at the end of the day. So I think I'm excited to see how, I think in the next 10 years, we're going to see a lot of ownership models and more innovation in this space.
Yeah. We have time for a few more questions. Don't we? There are a few.
Online.
All right, so a couple more questions. I think we have time for two more. There's one of the questions says, do you have an example on how network tariffs can be reformed, including retail tariff innovation, to incentivize microgrid CR household batteries, EVs, and then also, I guess, to incentivize higher consumption during times of peak supply?
Yeah, I think there is a very good example of a project going on right now. Is Project EDITH. EDITH, EDITH.
Okay.
Energy Australia and Ausgrid are part of that project. So Ausgrid is the one leading the project, and it's about dynamic network tariffs. So really trying to incentivize flexibility for the assets that have flexibility, or customers that have flexibility, to change their behavior when the network needs it. So I think that, that would be, if you're interested in that network tariff part, is something to keep looking at. And
there's another question from Nick. It says, great presentation, by the way, for you.
Thank you.
And then the question is about the Tanagala study. The question is, you know that tariffs could be used to make the battery help the system as opposed to chasing spot and FCAS, thereby increasing peak demand. So did you consider dynamic connection agreements? And then the follow-on is, it seems like there are different schools of thought on economics versus engineering for managing the system. And location marginal pricing just seems like it would have high transaction/administrative costs. Billing providers will have conniptions. So I guess the crux of the question is, did you consider dynamic connection agreements?
Yes, I mean, no, and yes, in a way, but I think the first answer is no. But I mean, this was in the end of the day research, and I was doing, I had the network data, so I was actually considering the actual network and the power flows and voltages. So of course, there was a constraint of the network needs to be operated in a safe and reliable manner. But I didn't so in a way, yes, but I didn't formally as it's done in the industry. So constraints were met. I guess that's important. And I guess on the pricing and engineering, I think it will be a trade-off. I think both aspects. In the end of the day, you need to, incentivize these assets to provide benefits, but the engineering part is there. So it's a trade-off between complexity and economic incentives.
All right, thanks, Carmen. Well, thank you all for attending today. I think it's time for us to wrap up this seminar. Josie for helping. Round of applause for Carmen.